Dual scan. In this video, we are going to see about dual scan. Dual scan displays are no longer used on portable computers. However, you might encounter them on older systems. Dual scan displays are an improved version of passive matrix displays. Both are controlled by an array of transistors along the horizontal and vertical edges of the display. For example, a 1024 x 768 resolution display features 1024 transistors along the horizontal edge of the display and 768 transistors along the vertical. The transistors send out a pulse of energy and the individual LCDs polarize at varying angles to produce the picture. Dual scan screens split the screen into a top half and a bottom half for faster response. Dual scan LCD displays are dimmer, have slower response times, and feature a narrower viewing angle than Activematrix screens. The main advantage of dual scan LCD displays is that until recently they have been far less expensive to replace when broken. For the reason, many companies have selected portables with dual scan displays instead Activematrix displays. Keep in mind that a portable with a dual scan display cannot be upgraded to an Activematrix display because the interface to the system is completely different. Passive matrix panels generally use super twisted pneumatic, that is STN technology. These panels are commonly used on notebook systems where they provide adequate display quality at a reasonably low price. Only the least expensive desktop FPDs use passive matrix technology, which should be avoided for its low display quality. Activematrix. In this video, we are going to see about Activematrix. Activematrix refers to screens that use a transistor for every dot seen on screen. For example, 1024 x 768 Activematrix LCD screen has 786 432 transistors. The additional transistors put the active in Activematrix, making them nearly as bright as CRT displays. They also offer wide viewing angles for easier use by groups of people and tend to display rapid movement and full motion video with less blur than dual scan displays. Until recently, Activematrix LCD displays were more expensive to replace when broken, and computers with these screens were more expensive to buy initially. However, the widespread popularity of Activematrix desktop displays and improvements in protection capacity have enabled Activematrix panels to replace dual scan in all price ranges of portable computers. Activematrix LCD displays are also used in increasing numbers of desktop computers. Unlike portable Activematrix displays, these displays are attached to the video card or built-in video port the same way that standard CRT-based monitors are. Most plug into the VGA port, but some high-end displays use the DVI port found on mid-range and high-end graphics cards. Activematrix panels generally use thin film transistor, that is TFT technology, and are superior to passive matrix in every respect except price. Flat panel displays. In this video, we are going to see about flat panel displays. The term flat panel display, that is FPD, refers to a class of video devices that has reduced volume, weight, and power requirement as compared to a CRT. Nearly all modern flat panel displays use LCD technologies. Most LCD screens are backlit to make them easier to read in bright environments. Flat panel displays are increasingly important in information electronic products. Compared with the CRT, that is cathode ray tube, used in traditional televisions, FPDs are thin, lightweight, and power-efficient devices that present images without the bulk of a picture tube. As a result, FPDs represent a large and rapidly growing industry worldwide and are expanding into an increasingly diverse set of systems. The largest demand for FPDs is for use in computers, mainly portable systems such as laptops, notebooks, and handheld personal digital assistants, that is PDAs. These electronic devices and many other consumer electronics use a type of FPD called liquid crystal displays. Flat panel displays are categorized into two. They are emissive displays, non-emissive displays. Flat panel displays, that is LCD. In this video, we are going to see about flat panel displays, that is LCD. A liquid crystal display, that is LCD, is a flat panel display or other electronic visual display that uses the light modulating properties of liquid crystals. Liquid crystals do not emit light directly. LCDs are available to display arbitrary images, that is, as in general purpose computer display, or fixed images with low information content which can be displayed or hidden, such as preset words, digits, and 7-segment displays as in a digital clock. They use the same basic technology, except that arbitrary images are made up of a large number of small pixels, while other displays have larger elements. LCDs are used in a wide range of applications including computer monitors, televisions, instrument panels, aircraft cockpit displays, and signage. They are common in consumer devices such as DVD players, gaming devices, clocks, watches, calculators, and telephones, and have replaced cathode ray tube, that is CRT displays, in nearly all applications. They are available in a wider range of screen sizes than CRT and plasma displays, and since they do not use phosphorus, they do not suffer image burn-in. LCDs are, however, susceptible to image persistence. The LCD screen is more energy efficient and can be disposed of more safely than a CRT can. It is an electronically modulated optical device made up of any number of segments controlling a layer of liquid crystals and arrayed in front of a light source, that is backlight or reflector, to produce images in color or monochrome. By 2008, annual sales of televisions with LCD screens exceeded sales of CRT units worldwide, and the CRT became obsolete for most purposes. Flat panel displays, LED. In this video, we are going to see about flat panel displays, that is LED. Light-emitting diode displays are another common type of flat panel display. LED display consists of LCD panels that are backlit with LEDs, which are the same type of lights that are commonly used with consumer products. In addition to standard LED displays, there are several emerging types of LEDs are there. Organic light-emitting diode displays use layers of organic material which emit a visible light when electric current is applied. Each pixel on the OLED display emits visible light in the necessary color. Because OLED displays emit a visible light, they do not use backlighting. This makes OLED more energy efficient than LCDs and LEDs and lengthens the battery life of portable devices using OLED displays. The other advantages of OLEDs are that they are thinner than LCDs, and so displayed content is visible from virtually all directions, and their images are brighter and sharper than LCDs. OLED displays are incorporated into many consumer devices, including digital camera, televisions, and smartphones. Flat panel displays, that is AMOLED. In this video, we are going to see about flat panel displays, AMOLED. Flat panel displays, AMOLED. AMOLED, that is Activematrix organic light emitting diode, is the display technology used in smartwatches, mobile devices, laptops, and televisions. AMOLED, that is Activematrix organic light emitting diode technology, is now often seen in its next generation Super AMOLED guides. With these displays, individual pixels are lit separately, that's the Activematrix bit, on top of a thin film transistor, that is TFT array, that passes electricity through organic compounds, that's the OLED bit. It is a newer technology than IPS LCD and improves on it in some areas while still lagging behind in others. The OLED technology uses anodes and cathodes for electron flow through a very thin film. Brightness is determined by the strength of the electron current. Color is controlled by the tiny red, green, and blue light-emitting diodes built into the display. The best way of understanding it is to think of each pixel as its own independently colored miniature light bulb on the screen. Colors are typically brighter with AMOLED and Super AMOLED, and blacks are darker because portions of the screen can be effectively turned off. This also leads to a theoretical improvement in battery life, but that depends on exactly how you're using the screen. That is, if all the pixels are lit all the time, the inverse can be true with AMOLED being more power hungry than IPS LCD. AMOLED traditionally suffered from burn-in, where pixel quality degraded over time, though this is becoming less of a problem as the technology improves. Also, in the negative column, they cost more to produce and can appear less sharp when viewed at very close range. Generally speaking, Super AMOLED also offers better brightness and battery life, though again manufacturers are working hard to minimize the difference with their own improvements. Flat panel displays, IPS display. In this video, we are going to see about flat panel displays, IPS display. Designers intended a newer LCD technology called in plane switching, that is IPS, to improve upon the limitations in viewing angle and the poor color reproduction of TN effect displays. The state-of-the-art in IPS displays 10-bit color channels, which is capable of over 1 billion colors. IPS does not suffer from the same color distortion from large horizontal viewing angles that TN effect displays have. Their superior color reproduction makes IPS displays much more attractive to professionals, artists, and photographers. Originally, IPS displays had poor pixel response times, but recent engineering improvements have made them comparable, that is around 5 ms to TN effect displays. Users who need the excellent color reproduction or viewing angles, example in multiple user settings, should find the increased price well worth the superior product. Active TFT displays. In this video, we are going to see about active TFT displays. A thin film transistor liquid crystal display is a variant of a liquid crystal display that uses thin film transistor technology to improve image quality such as addressability and contrast. A TFT LCD is an active matrix LCD in contrast to passive matrix LCDs or simple, direct-driven LCDs with a few segments. TFT LCDs are used in appliances including television sets, computer monitors, mobile phones, handheld video game systems, personal digital assistants, navigation systems, and projectors. TFT LCDs are also used in car instrument clusters because they allow the driver to customize the cluster as well as being able to provide an analog-like display with digital elements. Touch panel. In this video, we are going to see about touch panel. Touch panel. Mice, trackballs, and joysticks all take up work surface area. The touch panel allows the user to point at the screen directly with the finger to move the cursor around on the screen. Several different technologies are used for touch panels. Low-resolution panels from 10 to 50 resolvable positions in each direction use a series of infrared LEDs and light sensors, that is, photodiodes or phototransistors, to form a grid of invisible light beams over the display area. Touching the screen breaks one or two vertical and horizontal light beams, thereby indicating the finger's position. If two parallel beams are broken, the finger is presumed to be centered between them. If one is broken, the finger is presumed to be on the beam. A capacitively coupled touch panel can provide about 100 resolvable positions in each direction. When the user touches the conductively coated glass panel, electronic circuits detect the touch position from the impedance change across the conductive coating. One high-resolution panel, that is about 500 resolvable positions in each direction, uses sonar-style ranging. Bursts of high-frequency sound waves traveling alternatively horizontally and vertically are introduced at the edge of a glass plate. The touch of a finger on the glass causes part of the wave to be reflected back to its source. The distance to the finger can be calculated from the interval between emission of the wave burst and its arrival back at the source. Another high-resolution panel uses two slightly separated layers of transparent material, one coated with a thin layer of conducting material and the other with resistive material. Fingertip pressure forces the layers to touch, and the voltage drop across the resistive substrate is measured and is used to calculate the coordinates of the touched position. Low-resolution variations of this method use bars of conducting material or thin wires embedded in the transparent material. Touch panel technologies have been used to make small positioning pads for keyboards. The most significant touch panel parameters are resolution, the amount of pressure required for activation, that is not an issue for the light beam panel, and transparency, that is again not an issue for the light beam panel. An important issue with some of the technologies is parallax. If the panel is half-inch away from the display, then users touch the position on the panel that is aligned with their eyes and the desired point on the display, not at the position on the panel directly perpendicular to the desired point on the display. Users are accustomed to some type of tactile feedback, but touch panels of course offer none.